Welcome students to my channel, and today's topic is real numbers, and we are learning the real numbers. We have already solved exercise 11.1 and we have already learned the Euclid's theorem, and now we are going to learn how the prime factorization method. We have already learned the prime factorization method in class 9 syllabus. So today we will be dealing with some basic topics of prime factorization method, and also recapitulate how we can find the HCF and LCM of two numbers using the formula HCF into LCM is equal to the product of the two numbers. So these two topics we will be dealing today in today's video. So after learning this, after going through the video thoroughly, also please put a comment in my comment section, and if you have any problem or want a specific question or specific answer of a question, then also write that question number in the comment section. I will be putting a video on that, and I will show you, and I will post you the link. Without wasting much of our time, let's do this 26 and 29. Find the LCM and HCF of a pair of integer and verify that the LCM is a product of two numbers. So let's pick up this sum. This is practically exercise 1. This is exercise 1.2, and the two numbers are 26 and 91. So first we will do with the prime factorization method. We will do the LCM and HCF of these two numbers. Now let me find out the factors of 26 and 19. The factors of 26 are, we will divide the 26 here, is 2 and 13. 13 is not divisible, so it's 2 and 13. So 2 and 13. We will skip the one part, it is not required. And the prime factors of 91. We need to find the prime factors of 91 here. And we can find it using 7, 1 and 20, 13. So again it's 13 into 1. This equals to 13 into 1. So the common factors are we can find the common factors. We can easily check out the common factors of 26 and 19 is only 13, because out of these two numbers these are only the common one. Okay, hence is clearly, therefore the HCF, the highest power is only 13. There's no other common terms are there, so the highest is only 13. Now we will use this formula HCF into LCM equals to A into B. Okay, and we have the product of two numbers. We can have the product of two numbers. So first we write the formula HCF into LCM equals to A into B, and we have HCF is 13. This implies LCM equals to product is 26 into 91. So we keep LCM here, that is 26 into 19 by 13. This means 182. So we can find the LCM here also, okay, using this formula. But if we need to verify LCM into HCF equals to A and B, for those type of solutions we need to find the LCM of those two numbers. So we can find it. Suppose this part is not there, then how we can find the LCM? Now we can write the LCM is 2, 7 and 13, which means 182. From there we can find the LCM easily, and once we find the LCM, the left hand side is HCF into LCM. If we consider the left hand side of this formula, now we need to verify this formula. That's why we are doing in this way. We will find HCF is 13 and this one is 182, which implies 13 into 182, which is 2366, and the right hand side, which is the number A into B, the A becomes 26 into 91 equals to 2366. So both of them are solved. Now this is how we can solve this way, using the prime factorization method and also verifying those two formulas. We need to verify. Now the application, find the LCM and HCF. Question number 2. The question number 1 is only need to find the prime factors. This is very easy. If we need to find the prime factors, we will do a very simple division. 70 to 35, 5, 7. Always you have to the least number you can divide. Okay, this 7 equals to 1. That means 2, 2, 5, 7. 140. These are the factors of 140. We can also write 2 to the power of 2 into 5 into 7, because there is 2 2s are there, we can write that. These are the prime factors of 7. Next comes, we have already solved the second equation. We have also solved the second question. Come to the third question. Find the LCM and HCF of the following integers by applying the prime factorization method. So we have three numbers here. We have three numbers. Number 3. The numbers are 12, 15 and 21. And we need to find the prime factors. Okay. Let me write the prime factors of 12 is 12, 2, 6, 2, 3, 2, 2, 3. Okay. The prime factors of 15 is 3 and 5. Prime factors of 21 is 7 into 3. Okay. Then the common factors, we need to write the common factors. The common factors means the common numbers or the common which are present in all this 3, 3 and 3. So 3 is the only common factor here, hence this is the highest common factor. Okay, that becomes the highest. And the LCM of these three numbers are, see, the LCM is this one, 2, 2. Okay, then how many 3s are there? Highest is 1 3 only, so we will take 1. 5 is there, we will take 5. 7 is there, so we will take 7. Okay, and the highest common factor term is that it should be the same term written everywhere. Highest common factor as well as the LCM. Okay. The next sum is that number 4, given that the LCM, the HCF of two numbers is given, and the HCF of two numbers are given, we will come to the fourth question. The fourth question is a very interesting question, which says that the HCF of two number is 9. Then we have to find the LCM. So from this data we can find three things: the HCF of two numbers, we also get the two numbers, and the fourth thing which we need to find out is the LCM. So here we will apply the formula, which exercise 1.2 question number 4. The question number 4, HCF of 306 and 657 equals to 9, right? Then we have to find LCM of 306 and 657. We don't know, right? So what we know the two numbers, say A and B. A and B is 306 and 657, and the HCF we know, but the LCM we don't find. So 306 is 3102, 3 is 3 3 is a 9, 4 3 is a 12, 2 17, 17 1. So 306 is 3 3 2 17. 657 is, okay, so we have these two numbers. According to the formula, we have A into B equals to HCF into LCM. The HCF is 9, LCM is this one becomes 306 into 657, which comprises of LCM equals to 306 into 657 divided by 9. This 9 3 is a 27, 36, 9 4 is a 36. So the number formed is, even by multiplying, which is 22338. Let me solve the fifth question for you. The fifth question says that check whether 6 to the power of n can end with the digit 0 for any natural number. That means for any natural number, 6 to the power of n will come to an ending with a 0, let's say. Now if any number that ends with a 0, it should be divisible by 10, right? Or in other words, it should be divisible by 2 or 5, because 10 comes equals to 2 and 5. So prime factorization of 6n is p factorization of 6n becomes 3 into 2 to the power of n. We can write that, but this it has to be 2 into 5, but we have 3 into 2, so the 5 is missing here, 5 is not there, hence it cannot be solved with this one, cannot be with the 0 or end with 0. Okay, so in this way we can solve this question. Number 7th one, the 7th one is explain why 7 into 11 into 13 plus 13 is one of composite numbers. Okay, the question is very interesting. The question says that 7 into 11 into 11, 7 into 11 into 13 plus 13 and this number plus 5 are composite numbers. The first we will take this one, 7 into 11 into 13 plus 13. We will say why this number is a composite number or not, or if it is composite, why it is a composite number. First we need to understand what is composite number. See, 2 is a prime number because the factors of 2 is 2 and 1. 3 is a prime number because 3 into 1, but 4 is a composite number because 4 has a 4 into 1 and 2 into 2, so it has a factor 4, 1 and 2. That's why it is divisible by itself. 4 is divisible by 4 itself, that's fine, but 4 has also 2 factors which is 2 into 2, so that's why it is a composite number. So for the prime number, for this one is composite or not composite, we will check that. So let's take this number 7 into 11, so make it 13 common. 7 into 11 plus 1 we can write, or we can write 77 plus 1 we can write there. Come back here, we can write 78 also, that is 13 into 78, and now with 13 into 78, 13 into 6 is 78, so it has 2 factors, so it is not a prime number. It is not a prime number because it's a given expression, the 6 and 13 are factor, therefore it is a composite number. So it is a composite number. The last question is the 7th one. There are circular paths around a sports field, and Sonia takes 18 minutes to drive one around of the field, while Ravi takes 12 minutes for the same. Now there is a circular path, and Sonia needs 18 minutes is needed by Sonia, and 12 minutes is needed by Ravi. Ravi. Suppose these both start at the same point at the same time and go to the same direction. How many minutes will they meet up again in the starting point? So they keep on rotating. Okay, so they keep on rotating. She is there, he is there. So they keep on rotating. So after how many minutes they will just meet with each other. For these things there is a LCM is required, that is least common multiple. So we can find LCM of 18 and 12, which is 18 equals to 2 into 3 into 3, whereas 12 equals to 2 into 2 into 3. So 3 is common, right? Common. So in this case it's 2 to 3. The LCM is, so the highest power is 2 2, right? So we will write 2 2, and this one is 3 3. So this one is 3 3. So this one is 4. This one is 9. This one is 36. So after 36 minutes from the starting, they will meet again. So again we will come again with exercise 1.3.